This is going to be a reminder for everyone on the call. This is being recorded, so it'll go up on YouTube. So please keep yourself muted. As always, greatly appreciate you being here. For all the folks that may be watching the replay on YouTube, glad you're watching it. So I'm Tom Beebe. I am president of the IIUG, president of the Washington Area Informix User Group. I am a Informix consultant with XDB Systems. So Informix is kind of my jam. It's what I do. Uh, and wanted to talk with you all about enterprise replication, one of the major features of Informix that I don't feel gets enough love. So we're going to talk a little bit today about what it is, why you may want to use it, some beginner level getting into actually getting it set up and managing it. If you have deeper questions about some of the deeper aspects of it, they will, if there is interest, we'll do a follow-up session on that. So as always, feel free to reach out, give us feedback. It is always welcome. Also through this, feel free to toss questions into chat. Art can interrupt me if it is immediate, or he knows enough that sometimes he'll answer it himself, or we'll save any that are relevant to the end of the talk. All right, so really wanted as part of this presentation's iterated several times, but it started out as trying to put together a step-by-step guide to getting going with ER, and I've kind of expanded from there. But you will see in this, and if you're coming back to this later on, use the slide deck, and it should give you the specific commands to just get up and running with ER. But I also want to go into a fair amount more about why it matters. So talk about it. We're going to talk about how right now all of us, moving data around our networks, around our varying colo locations, or stuff in the cloud, or stuff on-prem, everywhere else. All the headaches that we have had over the years trying to manage getting our Informix data where it needs to go. ER can help straighten things out a little bit. So we're going to go through basically how to handle it, why use it, etc. So what is it actually? So it is a log-based replication that takes data from server A, sends it to server B. That is the basics of it. It is asynchronous, so data does not need to be real time from on the remote targets. So this gives a fair amount of flexibility. It is also one of the things that differentiates from HDR replication. You can do primary target, so one-way replication, or update anywhere. It's efficient, it's flexible, it is very resilient. So there's a lot of different things it can recover from that other replication methodologies may not. The other big advantage is it'll run on multiple platforms. So we have enterprise replication as well as HDR. For our disaster recovery. They are both great technologies. It's figuring out which one is right for you. The big point with HDR is it is an exact copy of your system. So you don't have to worry about configuring anything. You take a backup, you restore it to the target, turn it on, and now your secondary is exactly cloned to your primary. Real time, anything that happens on primary will happen on the secondary. And if you need a failover, things are 100% identical. It has some downsides, though. It doesn't replicate byte or text types. By default, it is real time. So if the secondary can't keep up, it'll slow down the primary. If there's a network problem, it can also slow down your primary. Everything has to be identical. Your Informix version, your operating, or at least your operating architecture, etc. It's the HDR is very simple to set up. If you do a schema changes, happen automatically. Add a new chunk, happens automatically, but it has to be a full copy of everything. It also does not require any particular schema changes to make it operational. There's one on config parameter of log index builds if you're doing the secondary RSS, but other than that, there's really no changes. Enterprise replication, it allows you to replicate just on a table level or even just on a particular row level. So you can get very granular with what you're replicating. It will let you replicate byte or text, so you can get that data over. So if you're running with the dumb blobs, this is a way to replicate the data. It is not necessarily real time. So you do not have the problem with HDR where if the secondary is slow, backed up, bad network, whatever, it's impacting the primary. Primary will queue up the data and send it when it can. Um, it's great for disaster recovery. It can also very much be useful for high availability by scaling your data set out. You can work with mixed environments. So you're running one system on HPUX on version 12. You got another system on Linux on 14. You've got an ARM system running 15. What have you. They can all talk to each other and send data around. So this can be a great thing for a mixed environment, and it can also make it be a very effective tool for migrating between architecture, because you can't take a backup off of Itanium, for example, or Power and then restore to Intel. They got to match. However, downside, it can be a little complex to set up. Is schema changes, you have to do that yourself. There are some features it gives you that help, but for the most part, you're going to have to change the schema on all of the tables. But again, it won't, a problem with replication won't impact the primary. It does, the one schema thing it does require is that all tables replicating either need a primary key, key added, or some kind of unique index. So just keep that in mind with your environment. You will need those added. So, reasons to use it. One of the biggest ones that I don't think it's used enough is you only want some of your data on the target server. This could be a case where you want to have a development box or a test box that you only want 1 year's worth of data or one state's worth of data or what have you, but you want real-time data in that box. Or you could have your accounting server to offload some of the data onto that where they only need the last fiscal year's worth of data, or you only need 5 tables to do that thing. Um, or maybe you only have, these core tables that you need as the real time, failover set. Everything else is cold, or, cold storage that you've got tape backups or whatever if something were to go wrong. A lot of different options and ways to configure it. Another thing is update anywhere. Rather than being stuck to the old model of you've got your one big Informix server, you can have 5 of them, 6 of them, horizontally scale it, spin up cloud instances with them, pull up AWS, spin up a new Informix environment, add it to the domain, and suddenly you now have another system that can handle all of your data. If you're running old byte or text columns and you need to replicate, I run into that a lot. Um, if IBM would ever and HCL would ever be able to put those into HDR as well, I'd be greatly appreciative, but right now it's not there. Um, Another one that I run into a lot is an unstable network. So if you're running 2 sites, maybe one of them's on a bad connection, bad switch, one of them's out in the wilderness. You're running IoT, for example, where you may only have network some of the time, or you may be on a satellite for one of the sites, or just it's not reliable Wi-Fi. It greatly will help with that because it'll queue things up until it can send them. You can also do it with the concept of feeder systems where you have multiple feeder systems. Again, IoT is a good example of this. You've got temperature sensor servers running all over the place that are feeding data from onboard Informix instances to one central server. ER will let you do that. Um, and again, spreading your data around. So, if you've ever looked at sharded data or things like that with a lot of the other databases, and Informix does support sharding, this will let you accomplish that. So replication types, there's 2 main ones: update anywhere, pretty self-explanatory. You can update the data anywhere you want. And when you update in one place, it'll filter to all the other systems. It may not be real time depending on your network. It's generally pretty close. Primary target, this is single directional, so maybe everything to a feeder system, or you have one central server that you want to push data out to everything. And you're not required to do all replicates on a server the same way. You can have one table that's one direction, one table that's another direction, and these other tables that are updated anywhere. It gives you a lot of flexibility depending on your environment. So, use case, and this is probably the most common and simple one, is I've got two servers. I've got one which is on version 12, one that's on version 14, and I need them to talk together. I need to be able to read data from both. I need to have an update happen anywhere. It's just a real simple set up ER for whatever tables you want. Tell it to, or actually specifically, don't tell it it's primary or single direction, and it'll be bidirectional by default. In this case, for the example, we're going to HPUX to Linux, and it just works. So another one is the reporting only server. This is one that I really would recommend people consider. If you've got the best example I have is you have your accounting team, the end of the quarter, the end of the fiscal year, they've got all of their reports to run. A lot of places I've been to, these reports are expensive, heavy CPU usage, heavy IO, and you watch the CPU of a system hitting the end of end of June, and suddenly you're spike into 80% CPU usage. If you set up a reporting read-only server that you replicate the tables the accounting need, or even just the data the accounting team need, maybe they don't need everything, they just need the last 12 months of data. You can then have a much smaller instance with better indexes for what they're doing. And now all of their reporting is against this other system. It's not impacting your main server. So you don't have that spike on it. Another example would be, and this is a lot of the horizontally scaling I talk about, is for places that are commercial, doing sales around the holidays, for example. We've all seen the stats where come December time, you go 300, 400% sales from your normal. Great. Just spin up a couple of new Informix nodes for that, whether they be cloud-based or on-prem. It doesn't matter as far as the ER goes. And just connect them in, and then set up your servers for your application to point to a single one, point to round robin them, set up a load balancer for it, what have you, lots of options. But now you have multiple servers. You're not limited to a single one or a single point of failure or a single point of slowdown or anything else when you're trying to get everybody's holiday gift giving, sales in. When you really need that uptime, you really need that performance, it lets you do it. So feeder servers, again, you have one single main server that is, some kind of warehouse or data repository with multiple feeder systems feeding to it. Normally, in this case, it would be all single directional with all of the outside servers only sending data to the main server. Again, depends on your environment. It may be some level of data going back, or updates that happen in the main server get replicated back. It just depends on your environment. The really nice thing with this is, because you can use where clauses in your definitions and in your repairs, you can have multiple feeders going to the same table on the central source. And if you do a repair or you need to do a refresh or something else, you're not going to blow each other away. You can set it up so that these rows are controlled by this server, these rows are controlled by this server. So when you do a repair, you just add the where clause and go, all right, I only want to repair from server 3. And it'll only then handle those particular records. So you can go in and really get that level of configuration. So you don't need sales table server 1, sales table server 2, etc. You can have it all go to a single source, and you don't need to have some kind of outside application or an ETL tool or something like that to be able to manage the data. You can do it all natively through Informix. I also want to add that ER itself is built in with the product. There is no extra fees. There are limits on some of the lower versions for how many servers you can have on the network. Please consult your Informix sales representative for information, or check the IUG website. We've got it broken down pretty well. So another use case, and this is a little more complex one, but this is actually based on a client I have where You've got a legacy server running HPUX, our central warehouse server that is our you know big server that handles everything. We've got another feeder server that's on Linux, and then we've also got a testing server. So we have all of these different tables: stores, sales, customers, inventory, our standard stores demo database. And our server one, that's a read only. All that's going to do is get a copy from production. Our server two, our main server, that is read write on most of the tables. But let's say the sales are only feeding in from our feeder system. So that one we want read only for that side. Whereas for our feeder system store three, we want sales and inventory to, be able to be both read write because we want sales coming into the store to then go down to the other servers. But the customer list, maybe customers are only defined from some outside application. We don't want those coming from the store, so we want that one to be read only. And then our testing server, we don't want anything from the testing server flowing back up. That's entirely read only. Again, these can be as complex or simple as you want your environment to be. It gives you those options. Some terminology when we're going through this. Our domain, which gets real confusing when you're also dealing with Windows systems, but our domain in this case is our entire cluster of all of our ER nodes, all of the replicates inside, et cetera. Everything that is inside one particular set of ER servers is the domain. An Informix instance can only be in one domain, so you do need to keep that in mind. A node is an individual server. There's a couple of different types we'll talk about. A replicate is a table or a set of columns that are being replicated. So anytime we say replicate, it is whatever level that we have defined. A replicate set is a feature that you can go in and actually group a bunch of replicates together. So if you need to say, I want to stop or start all the replicates for this server of this type, you can go do that with one command rather than needing to issue it for each. Then we have ATS and RIS. What this is are things you can pass when you're defining a replicate that if a transaction fails for some reason, it'll write out a file. And those files can either be informational or you can have it reread and replay those files if you need to if something got missed and now needs to get rerun. So those are there as options. So when you see us say ATS and RIS, that's what that's about. ATS is for the full transaction. RIS is for the individual row. So the node types, we have root nodes. These are supposed to be attached to all generally first level servers. These will have the full system catalog. So every replicate anywhere on the domain, the root node should have. The non-root nodes don't necessarily have the full catalog, but they're meant to connect to the root nodes as well as any leaf nodes. And the leaf nodes only have the local catalog, and it only can connect to a single non-root or a root node. So these are meant for the one standalone server. They will not connect to other servers, even if you have multiple. So it is purely this will only attach to a single source. So node types, again, this is just a little example. So we've got our root nodes of Chicago, New York, and DC. You'll see me use this example a lot, that all three of those are root nodes. Everything can connect to them. Then off of DC, we've got Baltimore's non-root node sitting out there, and New York has Boston, Philly under it. And then Boston has a leaf node of Providence. So Providence will only talk to Boston, but Boston can talk to Philly or New York, and New York can talk to pretty much everything other than Providence. So conflict resolution, these are fun. This only really applies if you have overlapping data or update anywhere. Conflict resolution in this case is if you have two rows that are going to have some kind of problem. You update let's say you have a product quantity, a product table that has quantity on it. You sell a product on store one and the same product on store two at the same time within a second of each other. And so one transaction comes in going, our quantity is now 3. Another transaction comes in from the other side going, our quantity is now 2. How does Informix handle that? We've got these two transactions saying the same column and same value should be different. And we have some options here. Always will mean that whatever one, it always applies. So whichever transaction comes in last is what it's going to be. Um, Ignore means you do not resolve conflicts. This is generally used for one-way replication. Timestamp will be the one with the most recent update based on the timestamp on the row. And where that difference from always is if a server is offline, or, the network's down, whatever, but it's got a newer timestamp by the time that it actually hits the server, the central, whatever the target server is, it'll use the timestamp of the record, not just when it actually hit the server. Uh, Delete wins just means if there is an update and a delete at the same time, the delete is what's going to be taken. Otherwise, if it's just going to treat it as timestamp. The other neat thing, if you want to really get complex, is you can use a store procedure. So you can actually put together an SPL that you can put in whatever logic you want to handle it. Like maybe you say system A has priority of system B. So if there's a conflict, always give it to system A. Depending on your environment, whatever's going to work best, you can make this as simple or complex as you want. So we're going to go through the setup steps. So this is going to be the case for every system that we want as part of this domain. First thing, we do need a smart blob space. This is where the actual queue, the records are stored when they're waiting to be sent. So consider sizing wise accordingly. I'll give some tips in a minute. We also need a DB space for our transactional data. You can use an existing one or create one just for this. It's usually not a bad idea to have one standalone. Same with the DB space for our syscdr database. So this is a system level database that'll be created just like sysmaster or sysusers, etc. When we actually initialize ER for the first time. We need to make sure that we can connect to all the servers we want to replicate with. So I generally recommend just use DB access, connect from target A, system A to system B, and then try the opposite direction, system B to system A. Some of the biggest headaches around getting ER set up is, trying to actually you're trying to connect and then nothing's working, or you're getting a weird error or whatever, and then you spent an hour on it, and then you're like, oh, I forgot to actually set up trust between these two, and these two servers can't actually talk. Or the port's blocked or something. So make sure that the servers can talk. I will also note that if servers, even if they are not replicating against each other, but if they are root nodes, will take any new replicates as part of the system catalog and try to validate. But if new root nodes cannot then talk to the systems that are getting the replicates, you will see errors in the log. It doesn't actually break anything, but it does get annoying and fills the logs just with notes about can't connect to server, etc. So make sure there are sufficient logical logs in all the systems. That is the same with HDR, where you want to make sure you've got enough logical logs to, even if things are really busy, you're not potentially running low and hitting a long transaction, because that's always painful. SQL host, there's a couple of notes on that coming up. One thing I have noticed, and I don't know that this is an official rule, but I have found it being a headache or sometimes not working without it, is make sure that your DB server name is the TCP connection you're using. If you've got a shared memory connection, make sure to put that as one of the DB server aliases, not the primary. And then also, and I've made this mistake on a number of occasions, make sure to create your ATS and RS directories in advance. Make sure they'll have some space available, because if you've got something that goes terribly wrong on a load job, suddenly you may be spooling out a lot of transactions into those directories, so make sure they don't run out of space. So on config changes, So our CDR DB space, we want to put something in this. By default, it'll go in root DBS. I don't recommend it. I don't like things being in root DBS. So if nothing else, create a small DB space for it. Unless you have a very, very complex system, the CDR syscdr database will be very small. The second one is our QHDR DB space. So this is where our record headers will be stored. This is a standard DB space. Um, so it is 110 bytes per record. And you can consider basically in your queue, if you want to do your math for this, in your queue, in the worst 72 hours you possibly could ever have, your holiday rush, you know, whatever, end of season sale, whatever it may be, the number of transactions, if your system network goes offline, that it might queue up. So you go, all right, over the holidays, we sell 50,000 products. It's going to be, 500,000 transactions. It's going to be 110 bytes per record. That's per day, times that by three. Okay, that's the space we need for this. It does not hurt to give it more space or to put it in another large DB space, but just don't run out of space on this. I normally recommend at least 72 hours and a lot of times 96 hours for your sizing estimate. The reason for that is because if you clock out on Friday at 6 p.m. and something that night goes horribly wrong and you're out of town or what have you, you want to make sure when you come back in on Monday that you have not exceeded your system limits, that you're not filled your logs, whatever. You want to give yourself as much breathing room as you can. The next one is the CDRQ data SB space. So this is where the transactions themselves, the data actually lives. Same thing, 72 hours of storage. You can have multiple ones defined, so you can have several that'll get used if you need to have failover or split up or what have you. So just make sure you get plenty of room for this. It does not hurt to over allocate. I used to say disk is cheap. I think we've all seen disk prices these days. It is still cheaper than having data. I shouldn't say data loss, but having to go deal with resyncing data or dealing with the added overhead of everything that goes into a cleanup job if we run out of space. So next thing, we need trusted connections between all of our servers. They need to be able to connect without passing a username and password. So this is using the old style host equiv, which I don't really recommend. Our hosts also don't recommend. I will tell you that our hosts no longer, knock on wood, hopefully you're not still using RSH. Doesn't do anything other than Informix looks at it, but it will often fail a security audit, even if it doesn't open any ports for you, because the old RSH commands were reliant on it, even if you have them blocked or don't even have them installed. So what I recommend is there's an Informix config parameter, remote server CFG. And what you do is you use that to point to a specific file, generally lives in informix/etc, and you put your servers in there. So, and you say the server and followed by the username that it's going from. Normally with ER, we're going on the Informix level. And that way you don't have to worry about any security audits seeing our host files and freaking out, and gives you a more secure way to actually define your system, your connections. So that I recommend it. If it's an untrusted network, there is on password as an option. So SQL hosts. So we need to go set them up. Every connection needs to be part of a group. So what we want to do is give it a group name. It needs to be a unique identifier number. So that's the I equals 10. Make sure that every server in your domain has a unique number. You will get an error and it won't join the domain if it overlaps. And make sure that every system that needs to talk to each other has the full list in their SQL hosts. You can also use Connection Manager for this, so that is certainly an option. So we just have the group name and then the TCP name. I don't know why it is actually required. Madison Pruitt said it at one point, maybe Art remembers, but they do it for identification purposes. So you can name them whatever you want as long as the name and the ID number are unique. And then Make sure, yeah, make sure everything is in everybody's SQL host files. So sample is we've got Chicago, New York, and DC. I said I'd be using these as an example. So each of the three servers would want the same SQL host entries, and each one is in their own group. So trusted hosts, I'm just using our host here, which is fine from a technical standpoint. We just give it the host name and then the Informix user. And then you can use DB access with the connect option to verify they can talk to each other. There are obviously other ways to validate, but that's just the simple one for this case. If you see the error 951, and this is a common one that I've run into, is you'll actually see the full name of the system it's coming from. So in this case, it's at dc.domain.com. And the reason this will trip people up is it uses reverse DNS to actually find the host name based on the IP address it's coming from. And sometimes DNS is not configured correctly so that one IP address might be set up under multiple reverse DNS host names. So just depending on what DNS server it hit, it may get a different value. Or it may not be able to resolve at all, in which case it'll come in as an IP address. Or in some cases where you're going over an IPv6 network, you might actually get an IPv6 value or even an IP4 IP address that's on an IPv6 format. It's really kind of weird when you see that, but it does happen. The trick is just take everything after the at, and that's what you want to put into your R hosts or trusted host file. That's all you should need, and it'll tell you pretty nicely in the online log exactly what to put in. Again, if you've got multiple reverse DNS entries, first go talk to your DNS administrators and have them fix that. But second, you can put all the entries into your trusted host file. So it doesn't care which one it comes from, it'll still work. So next thing you got to do is we got to prep the data in the schema. Version 11, you have to either have a primary key or you can use ER keys. With version 12, you can actually now use the dash key parameter to use any unique index on the table. So it just needs something to be able to tell it that this is a unique row. So one of these is required. There's a couple of special parameters you can use also, like add CR calls here. I list will actually help you if you need to do conflict resolution or to do repairs, because it'll actually put in, sorry, the add CR calls is required if you're using timestamp CR. It's what actually keeps the timestamp. At the bottom here, I also have add ER key. So this will add shadow columns with a unique identifier there. So if you can't add a primary key and you don't have the ability to do unique index on the table, you can use the add ER key to be able to add a unique value that way without actually changing the columns that a application would actually see pulling from the table. So they are there automatically. Note that these are not in place alters, these, because it has to go in and calculate the values for each row. So just be aware it's like any other alter that is changing the rows in the table, and plan accordingly. There's also a third shadow option, add REPL check. This is really nice if you're planning on having a large table or a lot of rows that you may have to periodically check and repair, because this will add a checksum to the row that then makes it much faster to be able to do repairs, which we'll talk about in a moment. So defining our first node. So we've got our systems prepped. They're SQL hosts. They're talking to each other. We've got the on config set up. So we actually want to define our first node. And we're going to set up Chicago. So this is going to be our first root node. And the command is CDR define server. You'll find all the commands start with CDR. And then we're passing -A and -R. So we're telling it to use an ATS and an RIS directory. And then we do an -I, which is initialization, and then we give it the group name. You can do pretty much all CDR commands to remote systems with the -C. You can also do pretty much all of them through sysadmin tasks. It gives you options. So at this point, you'll actually see with the Chicago server, it building the syscdr database. You'll see it come online. This usually only takes a few seconds. And the syscdr database will be created in that DB space you defined earlier. And you're now up and running. You're now running ER. Congratulations. But it doesn't really do anything at that point. It just exists. The second thing is now we need to add a second node to the system. This is going to add another root node because we're not telling it any other parameters for it not to be root node. Same thing, we're giving it the dash A and dash R to have it be ATS and RIS directories. And this time we're passing dash I to initialize, but we're initializing um, for the New York server, and we're passing then the dash S to tell it what root server to connect to. So it'll initialize New York, and it's going to connect to Chicago to join the domain and get a full copy of the catalog. So after we've done this, and we've added one more just for DC, we use CDR list server, and it'll show us all of the servers on here. It'll show the last time the connection was active, what the current queue is. So this is how many transactions are waiting to send, the status, the state, etc. So if you bring it offline, it'll show it. If it's behind, you'll see a queue. If there's a network problem, you'll probably see it rather than connected, either connecting or disconnected. You can always manually bring a server offline if you want to. You can disconnect it from the domain and add it back, or sorry, reconnect it. So we've got a ER domain set up. Great. Now let's do something with it. We're going to create our first replicate. We're going to take the stores demo customer table and replicate it between Chicago and New York. So right here, it's the command cdr define REPL and then dash C Chicago. So we're telling it to connect to the Chicago server to define the replicate. We're going to pass the dash C always for our conflict resolution. We're then going to give it the replicate name. So the replicate is going to be called REPL customer. I highly recommend naming replicates in a way that are obvious for you. If you're running multiple replicates on the same table, don't call them REPL customer 1, REPL customer 2, REPL customer 3. Define them with something that is clear and obvious. REPL customer New York, REPL customer Northeast, REPL customer, shorts, whatever, REPL, sorry, there's inventory, REPL customer, A through F. So, something that is obvious. So when you're looking at the replicates down the road, you know what you're looking at. It's real easy to build it over time and then have a management nightmare of trying to manage all these replicates that you don't necessarily know what they are. The same problem happens if you have a lot of tables or even a lot of databases. If they're not clearly labeled, it can be tricky to try to maintain them all, especially if you are second generation owner of this system. So we're calling it REPL customer. And then the syntax is a little weird, but after you've used it a few times, it makes sense. Where you have in quotes 4 parameters. The first one is the database at server colon table owner dot table name. So this is the full effective Informix path to the particular table that we're looking at. And then the second parameter is what the where clause is, or the select clause, I should say, of what data do we want from this table. Most of the time, it's going to be select star from, but it may be select column A, B, C from, or select star from customer where customer ID is greater than 20. You can put in where clauses, you can put in other things. And then you do the same thing with your target, where our second server, same thing, where it's going to be for New York, and same thing we're doing select star from. So in this case, because we're doing select star from both, we're not doing any directions to tell it unidirectional. It means we've now got an update anywhere copy of customer. So any updates, any changes on either side will replicate to the other. So our output, after we've run it, you'll actually see the verification happen. So it starts and then hopefully it's successful on both sides. If it is not successful, it'll usually tell you why, missing key or conflict or something else. So once we run a CDR list REPL, we can run it on the customer, and we'll actually see here the state's inactive because it hasn't been started, our conflict status, our participant information, a unique REPL ID, and where it's coming from this particular server. So in the same token, then we can run it with dash C to tell it to look from the New York side, and it'll just show you the New York version of this. So we can just start it with CDR start REPL and then the REPL name. And then if we list it again, you'll see the state is active now. So now it is up and running. Um, Again, once you kind of have the system together, it's pretty easy. Just make sure that it is maintainable with names and such. So if we want to do multiple targets, we want to have three servers all replicating the table. All you do is add one more line or however many more lines you want to the replication definition command. So you can have it from as many, well, I'm sure there is a limit, but you can have it from multiple servers for the same table the same way or partially. So primary target. The difference here is just simply at the beginning of the definition for where the table is coming from, you add a P for the primary and then an R for all the secondary servers or all the targets. So in this case, we have Chicago feeding the stock data to New York and DC. So New York and DC both have R's before them, and Chicago has a P. They start the same way, and when you start, by the way, for any node, it'll start for all the nodes. You don't have to do it for each one. So now we've got that. We did a CDR list REPL, and in this case, if you look at the REPL mode, so this is DC, so that's going to be our primary. That's read write. But if it was the secondary, it's going to be REPL mode read only. So send queue, I'm just mentioning this. There's a bunch of CDR view commands. Our send queue will be one of the most common ones you may want to use. This will actually show you what is currently in transit. So you can see the records that are currently in the queue, what's in memory getting sent out, transactions that are spooled, ready to go, our data, our memory in use, etc. Our acts pending. If you're not familiar with acts, it's acknowledgments. So when I've sent a transaction, the target server will send back an acknowledgement of yes, I received the transaction. Where if you see a lot of acknowledgments pending, it probably means there's a network problem somewhere where it sent a bunch of packets and has not gotten responses back. So just keep an eye on all of this if you start having problems. So again, we have our primary, and then so our primary will show REPL mode primary. Our target will show REPL mode read only. So that'll tell you where the data is flowing, and it can also be a good way to double check your configuration because when you see it read only means you never have to worry about that you accidentally have it misconfigured and you're sending data to somewhere it is not supposed to go. So if you want to check your status and check the replicate to make sure your data is correct, there's CDR check replicate or CDR check REPL, where you give it the initial system, the master, where it would be this is the system that should be the accurate version, and then you give it the REPL name. And then it'll actually, there's a lot of different commands you can give to this, but it'll actually show you, the number of rows, the number that mismatch, the number that are missing, etc. And if you do a repair, it'll show the number processed. So if you pass the dash repair, it'll do that. And if you add a dash dash all, rather than adding a specific, it'll go to this one system. If you do all, it means it'll make sure that all the systems are in sync. So again, this will use logical logs during the process. This is one of the reasons why having plenty of logical logs are necessary, because it'll go through and handle all of the changes at one time to make sure the targets are in sync with the initial source server. So bunch of check flags are here for reference. One I will note is skip blob. If you've got a lot of large objects, byte text, smart blobs, etc., repair can take quite a while. If you know that those aren't changing, then you can use skip blob to go ahead and just not have to scan all of those. It'll save a lot of time if you don't think there's going to be an update to the blob, the blob data itself. And again, you can use the where clause if you only want to do specific rows rather than the whole thing. There's also sync replicate rather than check replicate, where that one will actually go through the whole table and make sure everything is copied. This is really good. It only looks at missing rows. It's not going to deal with rows that are not updated. It goes past the logical logs, so it does not use as many of them. And this is really the best way to do it. If you're populating a table for the first time, you need to copy all the data. You want to use sync. It'll just be faster. So other notes, again, everything can be run through the sysadmin database, task or admin functions. You can use SSL for this. There used to be a SSL specific set of on config parameters for it. Those have been, as far as I'm aware, at least in the documentation, removed as of 14.10 FC12, I believe. So just use SSL connections like you do normally. There's a lot of on-stack commands, specifically -g CDR, -g RQM, that are very helpful. If you go through the full list, there's a bunch of others. Those are the ones that I find to use the most. If you're on CDR error, this will actually show you any replication errors, and you can actually mark the ones that you have already seen. This can be really helpful if you're seeing problems crop up with defining replicates or starting them or anything else. There's also a CDR template option, so you can actually create a template of replicates. So if you bring a new server online, you can use a template to automatically add all the replicates it is going to need. So if you're spinning up an extra server to give yourself some more processing power, it's easy then to apply a template to it, and very quickly you can be up and running. You don't have to go and create everything manually. So cascading data, this is one thing I've seen missed a lot. Uh, by default, data is not cascaded. So if you're dealing with multiple ER replicates, so you have a replicate from DC to New York and then a separate replicate on the same table from New York to Chicago, by default, if you add a row to DC, it'll go to New York but won't go past that. If you wanted to go all the way down the line, make sure to use cascading. There's a flag for it. And when you're defining the replicate. So just as a note, so you don't get headache on that. Um, so again, you can create replicate sets for a group of replicates and manage them all at once. You can stop replicates if you don't want them queued up, or pause them if you want them just not to be sending data right now. So, and then you can pause and unpause as you need. There's grid, which is a little outside of the scope of this, which was introduced in later versions, or is, yeah, beginning of version 11.7, I want to say, where it actually allows you to do things like schema changes off a single command rather than need to do them by system. It works really well if all of your systems are effective clones of each other. You can replicate version before to version 9 or 10 or even 7 from a later system. It is not officially supported, so run at your own risk. You can also set up ER to only replicate on a schedule. This can work really well if you've got a system out in the field with a satellite that you only have it's only going to be online between 4 and 8 a.m. Because of line of sight or whatever. So you can do that. Or alternatively, if you wanted a system that was refreshed every morning with the latest data, you could do that. There's a lot of options with it. So some version notes. It's introduced in 7.2.2. A lot of different things. This has been one of those things that has not been promoted well enough, but has had significant improvements pretty much every release. Comes in 9.4, we get HDR and encryption support. With HDR, you can actually have it working with ER. You can have them in tandem and have it actually handle failovers. I highly recommend using Connection Manager if you're at that level. Um, 11.10 will allow you to truncate, allow on config changes. I'm hoping everyone's on at least 12 at this point, hoping you're on 14.15. So 12 introduced sharding support and handled time series. It removed the primary key requirement in favor of being able to work with the unique index. 14 introduced self-replication to actually do loopback replication outside of the scope of this talk. Very, very cool stuff if you need to use it. I believe Art's got a presentation on it. I'm sure more will come out. You can replicate to a stored procedure. So you can actually have it handle that as opposed to directly going to another table. A whole bunch of performance improvements throughout 14. And 15 was allowed cascading replication off of templates, which wasn't there previously. So if that's something that is important to you, yet another reason to go to 15. So I've got some links there in the slide deck. I'm not expecting anyone to write this down. So we've had a lot of presentations over the years. The cool thing with ER is, while it has been added to and improved, a lot of what is there of older references is still perfectly applicable. The core of it has not changed. They have just added new features to it. So even the stuff that is like, I got one from Nagaraj, who was a great presentation back in 2017. Um, Largely, I was focused on version 12. Pretty much everything in there is still completely usable today. Um, and the cascade information, in case that is relevant for what 15 introduced, I put a link there. So, questions in chat. I'm actually going to, because we're low in time, I'm going to come back to questions in one sec. Um, so, certifications. We've got the 15 certification out. If for information, go to the IUG website. So, it is now available. So, if you need to get your Informix certification, it is now out there. So we, as always, are seeking Tech Talk speakers. If you have a talk that you are interested in giving us, either a technical thing, something you are passionate about, or something that, hey, I did this really cool thing, or I've got this outside product that does this cool stuff with Informix, let us know. If you have not given talks before, we're happy to help you with it, help you put together a presentation, how do we do this, etc. I did about an hour one here. We're happy to do shorter or even longer if you need. Uh, Feel free to reach out. We'd love to hear more from the community. We'd also love to hear more ideas for things you want to see. So please reach out. We're very, very accessible on this. So we got Tech Talks upcoming. Jan's doing both of them. We got time series implementation using IBM Bob. So if IBM Bob is your thing, or you're using time series and want to know how it can work with AI, got that coming up August 20th. And then we have actually migration off of the 4GL green screens onto other options. There's more information in the description on September 17th. So information on those and registration is on the IEG website. Um, so, any questions? Anything anyone wants to add? Anything I missed? I am happy for feedback. All right. I don't see any questions. Hopefully, this meant that this was very straightforward and useful and everything else. Um, Really appreciate everybody being on here, taking some time on their Thursday. It looks like we're just at time, so I think I scheduled that well. So again, thank you for being here. If you're on YouTube, feel free, if you have follow-up questions or comments or anything else, reach out to me. My email's on here. I'm also Tom at iiug.org. And again, if you're interested in getting involved with the Tech Talks on either ideas or willing to give one, we always could use more feedback. So appreciate it. Appreciate all of you, and thank you very much. And Art, did you stop recording? I'm gonna hope so.